Okay, here's another sequence that we need to use a difference approach, method of differences, to find the nth term on there. You look at this, and the first question you should ask yourself, is it going up in even steps? 4, 6, 8, no. Is it geometric, as in 2 times 3 is 6? Is 6 times 3 18? No, I'd have to times by 2 there, and that's a fraction to time it. So there's no constant multiplier that turns terms into terms. So that's right. If it was me, I'd check, is it linear? I would check, is it geometric? And then I might look for some kind of Fibonacci, as in 2 plus 6 is 8. No, it doesn't work. Do you times the 2 to, no, nothing like that. So actually now I move on to differences, and I'm thinking maybe it's quadratic, maybe it's cubic. So let's get that. This is called the first difference. So 6 minus 2 is plus 4, plus 6, plus 8, plus 10, and plus 12. So you may see there's something going on. So whilst these differences are not constant, they do have a constant, like they're going up by 2 each time. So if I now take the second difference, so as in the difference between the differences, plus 2, plus 2, plus 2, plus 2, I now have a constant second difference. Now if ever this happens, it means two things. It means quadratic sequence, e.g. the nth term is going to be something with an n squared in it, some kind of n squared. Well, let's write it probably. It's going to be some kind of an squared plus bn plus c, some kind of quadratic nth term. So it means that, first thing. Second thing, actually, a is always half the second difference. Now, if we were in class, I would probably at some point in the lesson show you why this works, and I'm quite happy I can put stuff in it. But right now, seeing as time's a factor, I just want you to be able to do it. I want you to be able to identify when a sequence is quadratic and find the nth term. So I know that if a is half the second difference was 2, so a equals half of 2. So a equals 1, so I know I have a 1n squared, so which means there's an n squared term in there. It won't be all of it, but it's some of it, right? So then the next step is to write out the sequence n. So if I had n, I had the sequence, and then I had the sequence n squared. Let's compare them, because I know it's got an n squared. So let's say I have n, and n could be 1, 2, 3, how many terms do we have? 1, 2, 3, 4, 6, right? 4, 5, and 6. And then I could have un, as in what's the actual sequence? Well, it was 2, 6, 12, 20, 30, and 42. I'm going to now write out the sequence n squared, which means whatever n is, I square it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25, and 6 squared 36, right? Now, I know we've got some kind of n squared plus bn plus c, right? So I know this is there, and I know that the rule has to make it work for all of these numbers, right? I know this must be there, and I'll come into why it's at some point in the future. So whatever's left must be made up by this, right? So if I could work out the difference between the actual terms and this n squared, if I take the n squared bit away, what's left to everything I need to make up comes from the bn plus c. So what I'm now going to do is I'm going to take away, so I think in note you'll see it as some sort of kind of arrow like that. It's basically, it's the difference between the actual terms in the sequence and the n squared bit. So it's going to be 2 minus 1 is 1. 6 minus 4 is 2. 12 minus 9 is 3. 20 minus 16 is 4. 30 minus 25 is 5 and 6. So now I can, my bn plus c is this, right? So basically, what is the nth term of that? And if you look at it, well, look, if I had 1, 2, 3, 4, 5 and 6, well, I shouldn't really need, n is 1. I shouldn't really need to do this, but in the interests of consolidating the last bit, there's plus 1, plus 1, plus 1, plus 1, which means plus 1n, or just n. And here, if n was 0, this would be 0, so plus 1n plus 0. So I know I had the n squared in the whole thing, so the final answer is n squared plus 1n plus 0, which would look a lot better if I write un equals n squared plus n. And that does work, I promise. Look, check, if n was 6, I know the answer needs to be 42. 6 squared is 36, 36 plus 6 gives you the next term. And then I could use this to do all sorts of things. I could ask you, what happens if n is 9? You'd say, well, it's 9 squared plus 9, 81 plus 9, 90, and so on.